Hey guys, so today's aim of the experiment is the VLAN deployment in a network. In this experiment, we'll be seeing that how we are able to connect two pieces in different VLANs. So in our architecture, we have a server, a multi-layer switch, access switch, and the end devices. So in this network, we have the distribution, we have the multi-layer switch at the core layer, the access switch at the access layer, and the end devices connected to it. So the one important thing to remember over here is that the end device and the access switch are connected in the access mode. Access switch and the multi-layer switch are connected in the trunk mode. So when we say trunk mode is to understand the concept of encapsulation of the packets. So trunking in general means whenever, for example, whenever we are trying to pass a packet from VLAN 10 to VLAN 20, it doesn't know that it is in a different VLAN or it belongs to a VLAN itself. So whenever it sends a packet destined for the VLAN 20, it sends a packet from uh, the end device to the switch. Now in the switch, it decides that whether the packet which is intended to the end device is in the other VLAN or not. So over here, it encapsulates a header or a format in which using the protocol of 802.1q, wherein it tells the multi-layer switch that this is a VLAN configuration and the packet which is present is intended for the VLAN. So over there, the VLAN information has been provided, which forwards the packets to the multi-layer switch, and multi-layer switch understands the packet and forwards it to the switch 2 and switch to the VLAN 20. So in general, these three interfaces have been trunked so that the encapsulation protocol can be applied. And these three interfaces has been in the access mode. The interface between the server and the multi-layer switch is also in the access mode. So over here we have been divided the entire network in VLAN 1, which is the default gateway, which we'll be covering in few minutes. VLAN 10. So VLAN 10 is this area between the switch 1 and VLAN 10. So this is the PC 10. So this is the VLAN 10 configuration or the interface. VLAN 20 is the switch 2 and the PC 2, and VLAN 30 is the switch 3 and the PC 3. Now VLAN 100 is the interface between server and multi-layer switch, and the IP address has been assigned like 10.1.1.254, 10.1.10, 1.20, 1.30, 1.100. Similarly, we have configured the IP address for the switch as 10.1.1.1, 1.2 and 1.3, and the PCs in the VLAN respective VLANs. So now to configure this entire architecture, there are two main steps. First, we need to assign or configure the multi-layer switch, and then we have to configure the switch one. So we'll go to the commands. Yeah, I'll just minimize this. Just hold on. Yeah, sorry for the delay. Yeah, so now we'll be going to the configuration. So in the multi-layer switch, we'll first go to the enable mode, and then we'll go to the go to the configuration mode using conf space t. Then we'll assign, or just indicate that we are configuring VLAN 1, VLAN 10, VLAN 20, VLAN 30 is also there, and VLAN 100. So by doing this, we have configured. We have identified that we are going to set up this particular VLANs. In the next step, we go to the config mode again, and then we try to go into the interface of gig 1 slash 0 slash 20. So I think this is the interface between the multi-layer switch and the server. So over here we go to the switch port mode access. So over here we enable the access mode in this entire interface, and then we assign the VLAN. So switch port access VLAN 100 and end this. So over here we first assign the access mode, and then we assign the VLAN 100 to the interface between the server and the multi-layer switch. We end this, and then we again go to the configuration mode. Now our next step is to uh, encapsulate and trunk the interface between the switch 1 and the multi-layer switch 1. Sorry, access switch and the multi-layer switch 1. So for doing that, we use the we go into the interface G1 1 slash 0 slash 1. Okay, now we use the command switch port trunk encapsulation dot 1q. So this command is usually used to tell the multi-layer switch that we are using the trunking protocol over the interface, and just enable this by uh, entering this command. Now we activate the uh, trunk mode by using the switch port mode trunk. So the interface between the multi-layer switch and the access switch from the multi-layer switches port is been converted into a trunk protocol. Now we do the same procedure for the other two interfaces as well, which is G1 slash 0 slash 2 and G1 slash 0 slash 3. So all the three interfaces have been trunks using the similar commands. Now, to, now the next step should be to enable these virtual interfaces. So for that, we first go to the config mode. Now we go to the we go to the interface VLAN 1, and we activate the VLAN 1 by using the no shut command. We As soon as we make the no shut command, we assign the IP address to the VLAN 1. So over here we have already assigned it, that is 10.1.1.254, which is been assigned it over here as well. So now we assign the IP address to the VLAN 1 and activate the link by using this 4 lines of command. Similarly, we do this for interface of VLAN 10, interface of VLAN 20, and interface of VLAN 30 by changing the IP, configuring the IP address as 1.10.254, 0.22.254, and 0.30.254. So by doing this, we have told the multi-layer switch that, hey, look, I have three interfaces, five VLANs, and three VLANs have been connected to the access switch. One VLAN has been connected to the server, and one VLAN is the default gate. So all these configurations are done in the multi-layer switch. Now we move on to the access layer switch and try to configure that as well. So now first we go to the enable mode and then to the config mode. Now our next step should be, we have in the previous step we have trunk from this multi-layer switches port. Now we have to try to trunk it from the access layer port. So we go to the interface G0 slash 1, which is the interface from switch 1 to multi-layer switch, and we go to the switch port mode trunk and end this. So this command tells the access switch, or by using this command we tell the access switch that a trunking has been done on this interface. Then we end this command. And then we go to the config mode again. Now we use this VTP domain CCNA. VTP domain CCNA simply means that we tell the access switch that it has to enable itself for the inter VLAN routing. So whenever there is a interconnection or communication between the two VLANs, this command has to be used so that the access switch can be configured for inter VLAN communication. And then we end this. Now the next command is used is VTP mode client. So in general terms, VTP mode client means nothing but advert. We make the switch aware of the advertisements. So whenever a packet comes, it has to know that where it has to be sent. So this is a general command which we always use whenever we configure a virtual terminal port on a switch. And then we end the command, and then we try to move on to the next step. Next step should includes configuring the interface between the switch one and the PC one. So over here, our main aim is to assign VLAN 10 or configure the VLAN 10 in this interface. So that's what we have been doing over here. We go to the interface FA0/1. Then we go to the access mode, because as I said earlier, this has to be in access mode to be able to communicate. So now we go to the switch port mode access. We make the interface as in access mode. Now we assign the access as VLAN 10. So switch port access VLAN 10. So now the switch 1 is configuring a virtual LAN on this device as VLAN 10. Then we exit the command. Okay, now the next step is to now similarly we do this for this switch, the switch between switch 2 and PC2 for VLAN 20 and VLAN 30. One important thing to remember is that whenever we try to configure the end devices are always in the virtual LAN, and it always gets the IP address which has been assigned by the virtual LAN. So for example, I have the virtual LAN 10.1.10.254. So end devices will get the IP address in relation with the virtual LAN only. It cannot get an IP address other than that. It is been confined to that virtual network itself. Okay, now the remaining part of the of our configuration was to understand about the VLAN 1. So VLAN 1 is nothing but whenever a packet is sent and it has been forwarded to switch and multi-layer switch, access switch and multi-layer switch, there might be some few times where it is not able to understand that where the packet is destined to go or where the packet is intended to go. So in those conditions, the multi-layer switch, what it does is it forwards the packet to VLAN 1, which is the default gateway for the network. So over here, we go to the interface VLAN 1. We assign the IP address 10.1.1 and the default mask is 255.255.0. And then we apply the no shut command to activate the virtual LAN 1. And then we exit and we end. Again, we go to the config mode and we assign the IP default gateway as 10.1.1.254. So whenever a packet has been sent from, for example, PC1 to a unknown destination, the multi-layer switch will send all those packets to the default gate. So that was the purpose of introducing or configuring VLAN 1. I think that's it. Yeah. So by doing the entire experiment, we have successfully implemented the connection between end devices between two virtual LANs. So now we'll just try to quickly have a simulation. Simulation event list. So as we can see, yeah, so now the packets has been sent from VLAN PC1 to switch 1. Now the switch 1 will configure and go to the multi-layer switch 1. Multi-layer switch 1 will be in the encapsulated dot one queue format. Now switch 2 will receive the message and it will forward it to the PC2. So that's it for this experiment, and I hope you guys understand whatever I have explained it to. Thank you.